Hey guys, this is Wojtek from Jolly Monster Studio, and today we're going to take a look at how to modify our last tutorial where we had a mesh moving along a spline in order to simulate an elevator, and introduce a couple of additional effects. So in this case, we're going to modify our base class to leverage the movement component, but we're going to create some initial custom implementations that do some other stuff. Like in this case, we have particles moving along a spline, generating the JMS logo. Over here, we're going to introduce another type of elevator where our player actually moves along a spline, as well as apply some additional animation effects. And here's some fancy additional particles. And lastly, we're going to ensure that the mesh moving component that we had in our last tutorial still works. So all of these guys are going to use the same base logic, but have slightly different behaviors depending on the need of the game that we're developing. Always make sure to check out our Patreon for the blueprint version of this tutorial, and let's get started. Okay, so let's get started. First thing we're going to have to do is create some new classes to represent all of these additional objects we're going to be making. So we're going to go into our props folder, and we're going to create a new C++ class. We're going to make it inherit from actor for the time being, and then I'll show you how we kind of migrate some of the logic from the base class into these new children classes. So this guy is going to be our mesh moving spline actor. So we're going to use this guy to recreate our first bit of logic. Okay, then we're going to repeat the same procedure for the next class, and this is going to be our particle moving spline actor. Okay, and our last actor is going to be the oh my goodness, player moving spline actor. Okay, so with these three classes ready, we're going to get back into our Visual Studio and start doing some coding. So going back to our IDE, let's take a look at what we have to work with. So we have our moving spline actor, and this is our base class that we're going to leverage for a lot of our refactoring. And there's a couple of components here that we already want to start moving around into some of the children classes we created. Specifically, we've got the static mesh component, so we can start moving that around. And we also have a number of methods that we may want to override as part of this exercise. So we're going to make them virtual sort of as we go along, and that basically allows our children classes to inherit them. And I'll kind of show you what the difference there is. So let's go ahead and start fleshing out our mesh moving spline actor. So the one thing you're going to notice, and before actually we get started too far, I want to show you again that sometimes when you create classes, especially this new one, player moving spline actor, the headers are not always generated correctly. So again, this is referencing a folder, or it thinks it is, but it's actually one sort of folder up. So I'll never find the header, it'll never compile, you'll have issues. So just make sure to clean that up. I've already done for the other classes, so you can go ahead. Going back to the mesh moving spline actor, let's go ahead and migrate the static mesh component. So this guy is going to allow us to just handle the mesh movement work within this specific class, and then we don't have to sort of spread our logic around across multiple different definitions. So we have this guy. Let's go ahead and instantiate it. So our mesh component, and actually, you know what, let's be a little bit lazy and just lift this work out of our previous class. So you see I moved the property definition, and now everything is highlighted in red, so that means it's no longer accessible. So let's move this back into the mesh constructor, and you'll notice we don't have a spline component being mentioned here because this object currently has no reference to our moving spline actor. And to do that, we're going to modify the header definition for our mesh moving spline actor. And rather referencing the actor as the base class, we're going to change this to be our A moving spline actor. And you'll notice there's no definition. Depending on what sort of ID you're using, you'll get autocomplete for the inclusion. If not, just make sure the header is referenced as part of that. So now our class is going to inherit all of the stuff that is coming in from this guy. you'll notice the spline component is now accessible. And if we go into its definition, you'll see it's a public component, so it's visible by everybody. So that's cool. We can quickly reference those parent objects. So we have our mesh definition. Now let's go ahead and see what else we need to modify here. So in our moving spline actor, we had a trigger component that was being attached to the mesh component. So since we can't do that here because the mesh is now a child and this parent has no reference to it, let's get rid of this here from here. Go back to our mesh moving spline actor and reattach it in the child. So now the child has a little bit of custom logic saying, hey, the trigger component is still attached to the mesh because we'll move the mesh along the spline and we want to ensure that the trigger moves along with it. So there's a couple of these design decisions you need to be aware of when you're doing this sort of refactoring. And, you know, at no point in time should you take sort of shortcuts and try to retrofit things just so you get this sort of circular relationship going, and that can cause all kinds of issues. Okay, so going back into our moving spline actor, we were also leveraging the spline location to set the original point of the mesh along the spline point. So this is actually going to now get taken out, and in our mesh begin play, or our mesh moving spline actor, we can reference this spline location, but it's not accessible to us. And if we look at this logic, the spline location is contextual to the begin play and it never gets referenced. So why don't we take this guy and starting spline location, we'll call this variable. We'll make it private, or sorry, not private, protected. So only our children can access it. It's going to be a vector starting spline location. So now our base class has this definition. It will pass it on to its children, and our child object should now be able to gain access. So the begin play of our parent will get called, this value will get populated, and then our child over here will have it accessible, and off it goes. Okay, so a lot of the work has already been done. Let's go ahead and keep stepping through this logic. So our begin play also has the binding of the progress functions as well as the end function that gets called at, when the timeline finishes its execution. So we don't care too much about that for now. We want to keep the actual tick iteration of the timeline, so things keep moving along the line. But we now have this call here in our process movement timeline where we affect the mesh. Now, excuse me, the mesh is not accessible to our parent, so we need to override this method, let it execute its logic, and then at the end of it, move the mesh along the spline. So to do that, let's go back to our spline, moving spline actor header, and we are going to make this function virtual. And actually, let me just show you real quick. If we don't make it virtual, and we go into our child header, and I go to overriding members, and I look for process timeline, it's not accessible, right? Because it's not marked as something that I can inherit and override and sort of manipulate as a child of this class. So going back to our header, if I now mark it as virtual and go back to this guy here, let's go to overriding members. And now if I say process, you see you have access to this function. It's going to allow me to inherit it, override it, and now I can do some stuff within its logic. So let's go ahead and get into that. So let's open up our C++, or CPP file rather. Let's create this new definition. So you always want to call super of the method you're overriding in case it's doing a lot of initial foundational logic. If you don't call that, you will have very sort of strange effects because in our particular case, these locations and rotations will not be accessible to our child and this thing will just not move correctly. So let's grab this logic for the mesh Let's slide it back into our overridden process movement timeline method. And you'll notice we have the same problem as we had with the starting spline location. They are not accessible to our child class. We go back in here and we can say, okay, this guy is going to be a protected variable, both for the location and rotation. And we actually also want to take this value because this was specific to the mesh and move that back in here. And we'll work on that in just a second. But first, let's make these two variables accessible to the rest of our objects. So we had a vector of current spline location and AF rotator. Current spline rotation. Okay, things are accessible. And I don't think we have any major conflicts in the rest of this object. So reviewing some of our other functions, on the end, we're doing reverse play from start. On the overlap, where the player interacts with the thing, we're starting it. So these are all really handy things to have in your base class. I think we're done here for the time being. Going back to this mesh, one thing we want to do is, depending on how we're leveraging the parent definition, I don't necessarily want to modify this pitch on my parent. What I would like to do is grab a local instance of that variable and then make modifications to it within the scope of my child method in case there's other logic where I need that original value present. So let's say spline rotation equals current spline rotation. And we just say spline rotation, and we'll keep the pitch at 0. Okay, so there is our refactored mesh moving spline actor. Let's recompile and double check that everything works within our editor. Okay, back in our editor, let's go ahead and create this new blueprint from the class we just made. So in our props folder, we're going to right click, go blueprint class, and now let's see if we can find our mesh moving spline actor, and there he is. If you can also see, we have our object actor moving spline actor and mesh moving spline actor hierarchy displayed in the parent class window. So we'll select our mesh class. Let's call this mesh spline actor. And let's go ahead and make it look like the one from our last tutorial. So just a little platform that goes up and down. So let's go mesh. And I believe we were using cube shape. Let's go ahead and squish that down just a little bit. Let's make sure our trigger component is visible above the platform. Just make it a little bit bigger. There we go. And lastly, we're going to make the spline point directly in our blueprint go up rather than modifying it in the editor. So I'm just clicking on the last point because it's a 2-point line by default on the spline. We're going to change the Z and make it go up to 500. I think that should get us all the way up to the top. Now, I also want to show you how this is going to fail drastically because of one thing we forgot to do. So we go ahead and we start our, and we have a hardcore crash. And if you notice, one thing this is complaining about is the curve. So what we forgot to add to our blueprint is the curve. And more importantly, what we ended up doing is not putting any logic around the curve as an input parameter into our base class. So this value is actually quite important. Otherwise, the rest of this fails, as you can see, catastrophically. So as part of this refactoring exercise, we always need to ensure that anything that can be null and inaccessible to our objects should be checked for those null values. So in this particular case, we're going to say, hey, if our movement curve is not accessible, I'm just going to return the begin play function because I don't want to continue with implementing my movement timeline structure with all these additional details, specifically all the binding of functions, if I don't have a curve to move along. So let's recompile and go back to our editor. Okay, one catastrophic failure later, we're back in our editor, and let's go ahead and see if this works with our null check in place. Looks good. So let's go ahead and add the curve back to our blueprint. There's our movement curve. Recompile and see what happens. So very quickly, we were able to refactor our existing object, make it a custom implementation while leveraging all of that baseline logic in our moving spline class. And we got this thing working. It's behaving as expected. When I go off, it goes down. When I stand on it, it goes up. So we broke nothing, and we were able to create this base class. So let's go back to the editor and start working on our particle spline moving actor. Okay, so back in the editor, we're going to start fleshing out our particle spline moving actor. And the first thing we're going to have to do is create a particle component for this thing to actually generate particles with. So we're going to create a new variable, and this is going to be a U property. Visible anywhere. Blueprint. Let's say read only. Category equals spline. And we're going to make sure that the private variables are accessible. Private access equals true. Okay, and this is going to be a U particle system component. Particle component. And let's just make this a pointer. Okay. Let's go into our CPP class for this and start fleshing out the definition of this thing. So our particle component, we got to create a default subobject. And let's give it a name of particle component due to a lack of originality. Now the particle needs to be attached to the spline. So let's go ahead and ensure that that is accessible. And I'm just wondering, particle system component is incomplete. Oh, you know what? We are missing the header definition. So particles, particle system component. There we go. So always make sure to include your headers. For some reason, this wasn't being picked up immediately. Cool. So that's much better. And the particle component, we want to set up the attachment to, again, go to the spline. The spline component. Oh, right. It's not there because we still haven't changed the parent definition of this class to the moving spline actor class. Make sure we have the header included. Now, spline component is accessible. Excellent. So we have that available to us. We can now go ahead and start putting the logic for moving the particle along the spline. So similar to our mesh, one thing we have to do is override the process movement timeline method, because that's where all of the fun stuff happens. So going back to our particle header definition, let's make sure our process movement timeline is accessible. Cool. There we go. Now let's put in the definition for it. Great. So inside of this logic, we're going to make the particle component move along, side world location, current spline location. I don't think we really care about rotating this particular effect just because it's simple in nature. It doesn't really do too much. So that's the process movement timeline. We also want to make sure that we set the particle to the beginning of the spline, similar to our mesh. So particle component, set world location, starting spline location. We also want to make sure that this particle doesn't activate itself on start. So we want to, as you saw in the beginning video, when we interact with it, when we trigger something, that's when it should light up. So we're going to say particle component, set auto activate to false. But now we need some way of triggering this event. And you'll notice we only have access to the process movement timeline. And what we really need to get at is trigger begin overlap as well as end overlap. That's going to let us handle the visibility of those particles. So we're going to make these methods virtual as well. And then going back to our particle spline moving actor, we're going to override them. So trigger, begin and end overlap. There's our two new methods. There we go. I'm just going to dive back in here and make sure the definitions are available. Excellent. So again, call super on all of these methods because we want to do what these things are doing initially, plus add in our own logic. So on the begin overlap, we're going to say if our particle component is not active, so if no one's turned this thing on yet, particle component, set active, there. And likewise on the end overlap, we're going to turn off the effect. So if particle component is active, and again, we don't want to unnecessarily execute functions, so throw in a little bit of if conditional logic to ensure you're only hitting things when necessary. False. Okay, so we have the location of our particle. We have its activity being flipped on and off accordingly. We setting the starting location. We're saying auto activated equals false. Oh, and one thing we actually do have in our moving spline actor is the auto activate flag, right? So this we said, hey, do things automatically when we want you to. So the particle may actually benefit from this. So if in our begin play, if we have access to this parent boolean, we can simply say set auto activate to be auto activate. And that way by default, it's off. But if we want to override it, or designers want to override these blueprints, then they have that option. So let's recompile this particle spline actor and see what it looks like in the editor. Okay, so back in the editor, let's go ahead and create our particle moving spline. So particle, and there's our new actor. So let's go ahead and select that. Let's give it a particle moving spline as the name. Now let's see what this guy looks like. So we have our trigger component, we have our spline, and then we have our particle component. Now for the particles, I've gone ahead and created a couple of different particles here. So just some purple-green dots kind of flying around, nothing too fancy. But just something to kind of show that we have a custom particle moving along the spline. And let's give the spline some sort of shape. So it looks a little bit more interesting. Why don't we do a sort of pentagon? Oops. That was the tangent, not the spline. So let's clear this up. Okay, let's try this again. Let's gonna that, and we'll go back to the original spot. Now you'll notice that these splines are kind of angled, and I may not necessarily want to do that. So if we go ahead and click on the individual spline points, you'll notice we have the arrive and leave tangents. So that controls sort of the angle and exit of each curve. And we're just going to set all of these to 0. And if you copy one of these values as we navigate through each one of our spline points, we can just go ahead and paste them in. So we're going to make all of these curves nice and straight rather than angular the way we have them by default. So we're almost there. Okay, so we got this letter T. Let's go ahead and actually make this guy in the same location as the other guy, and then let's just straighten out some of these values. I just want to make sure everything is generally straight. For no other reason than just being a little anal. All right, close enough. Now let's go ahead and make our trigger component into a slightly different location. So let's make it go out here so it's visible. So when our player enters, this thing should light up. Okay, and let's go ahead and make our trigger component visible in the game. Okay, cool. So we got our particle. We've got our new blueprint. Let's drop this guy in here. Okay. And let's give it a rotation. Okay, and let's maybe lower it down a bit. All right, so there's our trigger component. Let's see what happens. Nothing. It just gets stuck. And that is because we don't have our curve set. So you notice we didn't get a null pointer failure and everything crashed, but we still didn't get anything working correctly. So there we go. There is our particle moving along the spline. And because we can be fancy about this now, since we have this base object, we're just going to make this thing start on its own. And it should stop. No, that's not right. Quick debugging session later, and we found the problem. So in our begin play for the particle moving actor, we're actually setting set auto activate, but we're not saying activate now. So we just have to change this to set active and then pass in our auto activate flag. Let's recompile and go back to the editor. Okay, back in the editor, let's make sure that, oh, and there it goes. So yeah, just a little bit of a misconfiguration or begin play, but there we go. We now have the particle moving along the spline. We have our auto-activate flags working. The trigger should still reset it. All this thing should still work as expected. And there we go. Okay, now let's go ahead and do the third implementation of our base class and have the player move along the spline. Back in the editor, let's go ahead and start defining our player spline actor. So the first thing we're going to do is convert it over to use our base class. So there's our moving spline actor. And make sure you include the header for it. And then we can start working on the methods we're going to override. So we want the process movement timeline. So this is going to make our player move along the spline. We also want the start and end of our trigger to do something with the player. So specifically, we want to capture them. We want to disable their movement, start triggering our floating animation, and then drop them off wherever they're intending to go. So let's go ahead and override the two trigger methods. We also want to now look at the end of our timeline. So the trigger start and the trigger end have their own sort of functionality, whereas the end of timeline we haven't really leveraged yet, but in this particular case we want to, again, let the player go when they reach their destination. So we're going to make this method, going back to our base class, virtual as well, and going back to our player, we're going to overwrite this guy. And that is on timeline, on, and movement timeline. There we go. Cool. So the last thing we want to do is we need to keep a reference to our player as we're moving them along the timeline. So we want to hold an internal variable of our player character class that will be set when we step into our trigger. So our UE4 fundamentals 14 character. And am I misspelling that? Live character. And yeah, we want to bring in this guy. So there's our character. And he's just going to be a null pointer for the time being. Okay, let's go back into our CPP class for the player moving spline actor and process all of these definitions. Okay, so for the initial construction of this object, we don't need to worry about instantiating any other objects. We just have the trigger and the spline. That's all that's going to be part of this blueprint. We don't need any meshes or anything like that. And then on the process timeline, this is where we want to set the actor's location, or the character's location rather, to the spline. So we're going to say if our character is present, so did we obtain this guy? And we want to keep the rotation as well sort of fixed, similar to what we did with the mesh, because we don't want the character to kind of spin out of control as it's rotating along the spline. We actually want him to kind of flow nicely, as we saw in the initial video. So similar to our rotation, so actually, you know what? Spline rotation equals current spline rotation. Spline rotation is going to set the yaw to 0. And that way we don't have the character flopping around everywhere. And we're going to say the character set world set actor location and rotation to current spline location and our updated rotation. Now, because in this particular case, we also want to catch the flight as the character is moving along the spline and let them jump out of it. We're going to make the trigger move along the spline as well. So when our character jumps out of something, it's going to cause the trigger and overlap to hit, and then something will occur. So we want to say trigger component, set actor, or set world location rather, current spline location. I don't really care about the rotation for the trigger. This is good enough for us. We don't need to set anything on begin play immediately. And then on our trigger overlap, we want to do a couple things with our character. Or sorry, we don't need this. So if the overlapping actor is of an instance of a player, so we don't necessarily want to do this for any character that overlaps, but just our character. So we're going to say, hey, is this guy overlapping? And if so, we're going to say character equals, and we're going to cast fundamentals character of our other actor. So that's going to set the value. And we can now do the inverse in our end overlap. So we want to set our character to a null pointer when we leave. So this object has no longer has a reference to where we're going. And on the end overlap as well, we want to say the trigger component set world location to the starting spline location. So we want to kind of reset it back to the beginning, wherever it was coming from. Okay, so we're setting the character, we're unsetting them when they leave. What else do we need to do? Well, on the begin overlap, we need to notify the character that he's actually in a floating state. So we're going to do a couple of things. We're going to say set is floating to true. And you'll notice this method is not currently accessible on our character, and we'll worry about that in just a second. But we always want to do the reciprocal of that. So character set is floating to false. Okay, so this is the flag that's going to tell our animations as well as our character properties that we're going to disable movement and flip them around. But the other thing we need to do is consider the event of I'm jumping out of my spline. How do I notify the thing I jumped out of that it needs to register some sort of additional event? So the trigger end overlap may be part of that, but in our case, we also want to be cautious and sort of ensure that we're always interacting with the thing that is interacting with us and sort of having this bidirectional communication between the objects. So the set floating is this object telling the character to do something, and then we may want something that does an inverse of that. So we'll worry about that in just a second, but let's make sure the set is floating is now propagated to our character. So you'll notice we don't have too much stuff going on in the player character currently. This is just the default third-person template. We do have a couple of extra input events that we probably don't care about, so I'm just going to get rid of these touch, start, stopped, and on reset VR methods. So let's get rid of that, and touch started, touch end. And let's make sure we remove them from the header, just so we're cleaning up a little bit. Okay. Now we need to define an internal state for our character that says, hey, I'm floating. So I'm going to create a private of Boolean. And I'm just going to say B is floating. We're going to create two new methods for get is floating. That's going to be a void. Sorry, not a void. What am I doing? A Boolean. And a void for set is floating. That's going to take a Boolean value. Okay. Let's go back to our character, CPP file. And let's implement these new getters and setters. Okay, so get is floating, return floating, and B is floating equals value. Okay, so there are two getters. Let's make sure everything compiles before we go too much further. Okay, everything's recompiled. So let's go ahead and keep implementing these player spline changes. One thing that we can start fleshing out here is you'll notice on the jump, we are not leveraging any custom methods. We're calling the base character's jump that the current class is implementing. So what we need to do is define a new jump method, and that's going to be the trigger to let our character detach themselves from the spline. So I'm just going to go into the header here, and we're going to create a new method. It says jump, and let's go ahead and define it. And here we can say character jump. And this is going to be our now updated definition. That way we can start putting in additional logic into the jump. So if you recall, a few minutes ago I was mentioning that we need to notify the thing that we're interacting with that something happened. So one of the things that we may want to do is examine who I'm interacting with. So let's say I have multiple objects that I can do stuff with, and they may have slightly different bits of custom definitions. So what I may want to do is say, okay, who am I interacting with? So interacting actor is A, and then define the actual signature. But I don't have this interacting actor, so this is one of these other getters and setters that I now need to define on my character to be able to allow the player moving spline actor, when we interact with it, to set itself as a pointer to our character. Hopefully this doesn't sound too confusing, but going back to our character, sorry, I'm just clicking on the wrong things here. Let's define a private variable for our interacting actor. And let's give ourselves, two new getters and setters that bring back these values and allow us to set them on the character. Okay. Back into the CPP file. Let's create these two definitions. So return interacting actor and interacting actor equals new actor. Okay. So now we can say that this interacting actor is of a specific entity type. So we can say player moving spline actor. And since we now know who this guy is, we can say, okay, I'm going to jump. I do want to execute my character's jump, but now I want to tell this this interacting actor to detach myself from it. So interacting, or reset itself back to the beginning, or some other event. So we're just going to cast this real quick. Interacting actor. And we can say spline actor on end movement timeline. So basically whatever is at the end of our timeline that's meant to happen when we exit out of this thing should take care of it. So that's now our jump. We have this interacting actor. We need to go back to our player spline actor and now set ourselves as a reference point. So we'll say character set interacting actor to this. And on the way out, we want to clear all of these references. Set interacting actor null pointer. And that way, we sort of have everything reset back to its original behavior. Okay. Lastly, what do we want to do? We want to ensure that the player is not moving as part of the floating activity. So we can still control the camera, but we don't necessarily want to move the character around. So we can do that really quickly. And I'm looking at the wrong class here. Let's go back to our player. When we set our floating value, we can say if I am floating, then what I want to do is say, okay, disable my character movement. So I can say get character movement component and set movement mode to none. So this disables all of my character's movement forwards, backwards, but I'll still be able to intercept the jump event. So once we have that in place, we have to do the reciprocal of that for the when we turn this option off. So get character movement, set movement mode to move walking. And if we were really good scientists, we would have captured the original movement mode prior to these reset values, so we can always go back to whatever it is. I just know that walking is sort of the default mode for it. Now, the other thing we also want to consider is because we're changing, let me just show you really quick here. In the process movement timeline, we're changing the rotation of our character. If we jump out too early, he may get stuck in a slightly different orientation. So what we want to do is when we go back to this walking position and we're no longer floating, we want to say set actor rotation to a 0 rotator. And that way, wherever he goes along the spline, when he jumps out, he's going to go back to vertical, and then he can resume his business. So let's recompile and go back to the editor. Actually, before we get too far, one thing I forgot to do is define the end movement timeline definition. So it has to have the same logic as our end trigger, so our character gets properly detached from the thing we're operating on. So we're just going to actually modify these methods really quick to say other actor equals character. So we only want to do this when we are of the same type. And then we're going to take this logic, and rather than duplicating it down here, so it's all the same, we're just going to create a private function that we can call in order to do this work. So we're going to say private, and it's going to be void detach character. And let's just go ahead and define this method here. So that takes our character logic. And then wherever we need to do this work, we can just go ahead and pass that in. Again, you want to refactor these things and reuse as much of it as possible. So let's recompile and go back to the editor. Okay, back in the editor. Let's see if we can get this new and last class working. So player moving spline actor as a new blueprint definition. And we'll call this a player moving spline. And let's go ahead and take a look at this last blueprint here. So we're going to need a curve. We're going to, we'll leave the trigger component. You know what? We're going to add just a static mesh so we can see what we're stepping on. And that can be a parent of the spline. Let's make a shape similar to our other one. Yeah, let's scale it down. Put it underneath this trigger so we kind of know where it is. And let's make this point similar to our last one where it just goes upwards. So let's do 500 as well. Okay, so there's our blueprint. Our player should be able to step on this thing and get floated upwards. Okay. And look at that. We have a player moving along the spline, but we don't have our cool, funky animations. And that is because we still need to enhance our player state management in order to let it know that we're floating. So we're setting the variable, we're flipping it back and forth, but our animation blueprint has no visibility into it. So let's go ahead and clean that up. This is great. I can't move anything, but I can still jump out. So when I hit jump, I get out of the thing, but if I fall on the trigger, it lifts me back up. Okay, so now to implement these animations, we can do it sort of the easy way by modifying the third person And in Blueprint, making a cast to our character, but we don't necessarily want to do that since this is a C++ class. Let's go ahead and create our new player anim instance, and you can watch the other tutorials I've done to get a better handle on how these things operate, but first things first, let's go ahead and create our new class. So I'm going to make this a anim instance parent. And we're going to put this in the player folder. So it's going to be our player anim instance. Let's go into Visual Studio and flesh this guy out. Okay, back in the editor, let's go ahead and flesh out our player anim instance. And I'm just going to kind of buzz through this because we already have a video on sort of the details of this, but hopefully there's still enough information here that you guys can kind of quickly catch up. If not, I'll make sure to link the video down below. So we're going to create the constructor for this. We are going to override two methods, native initialize animation and update animation. That's what it is. So we've got these two guys, and then we're also going to create a couple of additional properties. And if you recall, on the default animation blueprint for the third-person character, there is, am I in air? What is my speed? We also need to add the float state management. So am I floating? As well as the float angle, because we want our animations to sort of translate the character's animation back and forth depending on how he's floating along the spline. So we're just going to create a couple of properties. Edit anywhere, blueprint, let's rewrite, and category is animation. And this is going to be our bool, B is in air. Let's take this guy again, and this is going to be our float for speed. This is going to be our bool for B is floating. And this is going to be our new variable for our animation blend space to know sort of which angle he's moving on. So that's going to be a float. I'm just going to make a float angle variable. Oh, and lastly, because we want to cache the pawn of this animation blueprint, we're just going to create a instance of pawn variable. Okay, going to CPP for the anim instance. We're just going to flesh these guys out real quick here. So we're not actually going to do anything in constructor. Here we're going to say owner equals get pawn owner. And on the actual updates, we're going to do a couple of things. So if we don't have the owner, then we're just going to quit, and then we're going to say if owner is a so if he's of this kind, which is our player character, then we want to do some stuff. So we're going to say character by casting the owner. Okay, and off the character we can now say, what can we say? We can say B as in air, as in player, sorry. Get movement component and is falling. Ooh, not movement base. Is oh right. So you'll notice I don't get autocomplete necessarily on this component because this class doesn't have an instance to the header. So let's just go ahead and do this. Game frame. Okay, great. So now we can get the is falling flag off the movement component. we can get the speed of the velocity. Actually, sorry, the size of the velocity. So that's going to give us a float, and then we can say B is floating. This character is floating, and float angle is the character rotation, and we want the pitch. Okay, so that's going to give us a custom anim instance. We can then replace the one in our blueprint player character and leverage this one and then define our blend space. So let's go back to the editor and get this thing working. Okay, so back in the editor, in our animation folder under tutorial resources, we're going to create a new animation blueprint. So you can now see we have our player anim instance as the parent class. And for this, we want to pick the UE4 mannequin skeleton. That's just the one that's currently associated with the third-person character blueprint. So this is our BP player animation. And let's pull up the third-person characters, the default one. And you can see we've got the pawn owner, the is falling is being set, the length of the vector for the velocity. So basically duplicated all of this logic. And what we care about is these states. So I'm going to take these states and just copy them. Go back to our new player animation. Where's the state machine? We're going to add a new state machine on the anim graph. And when we step into the state machine, we're just going to copy and paste these state definitions. So we have on entry, idle run, jump start, etc. One thing we have to do, though, is these variables from the blueprint are gone. They've lost their reference. So we need to delete them and then say is... oh, sorry. Was that... is in air. Is in air. Okay. Let's reconnect that. This is our not in air. So you'll see these variables, like if we compile, you're going to get an exception. So we just need to replace this with get is in air. And I think that's okay. Okay, so our state machine is now 1, 2, 1 with this one. We don't care about the event graph, so this guy can go away. Let's go ahead and introduce a new state for our floating. So there's our floating state. And we want to make sure we go back. Oops. What am I doing here? Go back. There we go. And we can enter this transition when we're floating. And we're going to leave it when we're not floating. Okay. So is floating, and you'll notice we don't have an animation for it. Excellent. So let's go back to our animation folder, and now let's go ahead and create a new blend space 1D. So all we care about is a couple of animations, specifically these 3 ones that we're just going to transition between. And let me just show you. So this is player floating blend space. So this is sort of the floating backwards animation. You can see he's kind of articulated back a bit. This is the lean forward and the normal. And we're just going to transition between those 3 depending on where the character is along the spline. Okay, so let's go back in here and we need to create a new pose. So we're going to bring in our BS player floating. And let's take a look at this blend space. So this blend space currently has no definitions. And on the left-hand side, you've got your axis definition. So this is going to be our float angle. And we're going to go from, I don't know, let's go 90, or sorry, minus 90 to 90. And that's going to give us that range that the float angle, the pitch of the character will update. So we can put the back, let's say over here, the forward over here, and the middle state over here. So as he floats, he should kind of move his hips around the spline point. Okay, so we have our float angle in our blend space, and get float angle as the input parameter to this. So I now should be able to say is floating, and if I set this to 90 and minus 90, he articulates correctly. Let's jump back into our project and see. Oh, actually, before we do that, go back to your third-person character blueprint. That's the one we're using, and make sure you pick a different animation blueprint. So we're looking for BP player animation versus the third-person animation. Okay, let's make sure this all works. So this all works, and jump crashes. So let's figure out what is going on here. Live character 149. Live character 149. So if interacting actor, we're assuming this interacting actor is set. In this particular case, he wasn't. So let's just add another null pointer, restart everything, and make sure this doesn't crash terribly once again. Okay, so with this additional null check in place, let's go ahead and make sure that everything works when we jump. Great. And now, there we go. There's our floating state, and we're going upwards. It restarts when we land and get canceled when we jump out. Okay, now the only thing we need to do is make sure that our floating angle is being properly propagated. So let's go ahead and, you know, let's create another spline point here, another one over here. We'll make this a fun trip for our guy. Just a little bit higher. This one like that, and we'll do this point over here downwards. Okay, let's see what this looks like. So, the good news is we're sort of getting what we want to get, but it doesn't appear, and this is a little bit sharp. Let's do that maybe. Let's see how this goes. Okay, that's a little bit smoother, but as you can see, he's not rotating correctly. So to troubleshoot that, let's go into our player animation, and in the event graph, let's just print out our float angle. That's this into print string, and let's just pop this out. Okay, so, sorry, not the duration, into the value. Okay, so 0 angle, 80, and, okay, so, I think we need to adjust our blend space here. So if these are 90, you know, let's make these 45, and that way the range isn't so wide. We should see more dramatic animation movements of the character. Yeah, and again, we sort of saw that, but let's readjust this just a bit. So BS floating player, forwards, backwards. So this should be when we're leaning in. 0.70. There we go. Okay. So it's a little bit fast, and we can adjust that. Let's duplicate slow movement curve. And this guy we're going to make run for, I don't know, let's say 10 seconds. Okay. Cool. So you can see as he's coming in and the angle gets a little bit steeper, his animations change. I just want to make sure we're happy with this. 45. Okay, let's make these angles a little bit weirder. Let's do this, and let's make this guy run over 15 seconds, just so it's just a little bit slower. And I guess it would probably help if I change this to the slow curve. Okay, there we go. Okay, so he's fully floating backwards. That's the articulation forwards, backwards. He kind of goes back to his regular position there, and then down, 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 and he drops. Awesome. So let's get rid of this print statement, since it's no longer of use. And there we go. There's our floating player. We can make the splines, do whatever we want. There's our particle one floating at the beginning. I can let this keep going. I can jump out of it. Cool. Yeah, pretty happy with this. As you can see, everything is still operating as expected. Things are all inheriting from our base class. Thank you guys for taking the time to sit all the way through all these shenanigans. And as I mentioned earlier, if you want to check out the blueprint version of this tutorial, please check out our Patreon. Otherwise, I hope to see you next time. Thanks for tuning in.